Based on a statistical analysis of solar systems discovered so far, one study estimates that there is at least one planet like Earth within 20 light-years. Astronomers may have already found it. Each night, in this control room at the La Silla Observatory in Chile, astronomers conduct the world's most intensive hunt for planets in the neighborhood of the Sun. They work with an older telescope, commissioned in the year 1977. It has a relatively small mirror, at 3.6 meters in diameter. But it's outfitted with a spectrographic technology that allows astronomers to finely parse the light of nearby stars. It does this by recording subtle shifts in their light caused by the gravitational tug of planets. Among their targets is a star that lies just below the constellation of Leo, 11 light-years from Earth. Ross 128 is a red dwarf star like Proxima Centauri. Orbiting this star within the habitable zone, astronomers have found a planet slightly larger than Earth. Because the star is relatively quiescent, the planet may not have endured destructive blasts of radiation. In the coming years, astronomers will use powerful ground telescopes to probe the planet's atmosphere. They are looking for the presence of biomarkers such as oxygen and other evidence of a habitable climate. They'll also look for clues to the early evolution of our own planet, and ultimately for an answer to the age-old question: are we alone in the universe? Should we ever decide it's worth going there for a close-up look, we might want to wait. Ross 128 is actually moving toward us. In the blink of a cosmic eye, 79,000 years from now, it will become our Sun's nearest neighbor. Proxima Centauri, TRAPPIST-1, and Ross 128 are among the first targets in what is shaping up to be the golden age of planet hunting. The transit exoplanet satellite TESS has found evidence of over 5,000 planets orbiting nearby stars that astronomers hope to scan in the coming years. Many are like those found around the star HD 21749, slightly smaller than our Sun, and 53 light-years away. The surface of planet C likely hovers around 400 degrees Celsius. It's so close to the star that it whips around it every 8 Earth days. Planet B is a gas giant 23 times the mass of Earth. Within a deep layer of clouds, temperatures average around 150 degrees Celsius. The Sun-like star Pi Mensa hosts a planet twice the size of Earth. Its surface temperature is over 900 degrees Celsius. Then there's this planet, around the red dwarf star TOI 700. Roughly the size of Earth, It's tucked just inside the habitable zone of its parent star. Following up on data from TESS, planet hunters used the powerful detectors of the James Webb Space Telescope to confirm its first planet. At 99% the size of Earth, it orbits the red dwarf star LHS 475. This planet will no doubt be the subject of intensive study in coming years. Inevitably, the discovery of planets around nearby stars has spurred debate about the imperatives of interstellar missions. The physicist Stephen Hawking was one of a growing number of scientists concerned about a cloud of uncertainties surrounding Earth's future. Pollution, overpopulation, war, climate change and ecological collapse. We have no choice, they say, but to develop the technologies needed to not only travel to other solar systems, but to survive in alien realms. The dream of settling distant worlds is as old as the rocket itself. Back in the early years of the 20th century, the Russian space visionary Konstantin Tsiolkovsky believed humans would one day ascend to the stars. They would evolve into a whole new species he called HOMO COSMICAS. Tsiolkovsky laid out the physics of the rocket. His famous rocket equation describes the basic principle of acceleration. It's the force of mass expelled at high velocity out the back of a rocket versus the overall mass of the rocket. Decades later, in the 1960s, with the space age in full swing, another Russian scientist, Nikolai Kardashev, described spacefaring civilizations as the product of a long-range technological evolution. He defined Level 1 as a planetary civilization with the ability to tap into energy equivalent to that of the sun striking our planet. At this basic level, a planetary civilization would exceed our current energy generating capacity by 5 orders of magnitude. It may take us centuries to advance that far. It may take thousands or even millions of years to reach Level 2, the ability to harness the energy equivalent of a star, or Level 3, the energy of a galaxy. In theory, a civilization with that degree of sophistication could wander the galaxy, mining raw materials from planetary bodies, while generating energy from technologies we can scarcely imagine. Advancing that far does not mean we can afford to abandon Earth. According to a recent rethinking of Kardashev's theories, maintaining the health of our biosphere will be crucial to the development of interstellar technologies. In this view, interstellar flight will flow from successful efforts to solve humanity's growing energy needs, with technologies that are more efficient, powerful, and safe.